Hello everyone, and thank you for joining me for another video. Now, this video is going to be almost like a bit of a precursor to trigonometry, to the actual content that we're going to be doing. Because what I'm going to run through in this video seems to be a kind of common source of confusion amongst some of the students that I teach when they first encounter the subject of trigonometry. So, trigonometry, as we know it so far, is the study of right-angled triangles. So I've drawn one here, and we are going to essentially just spend this video labeling the key bits of our right-angled triangle, the thing that we're going to be studying in this course. And this includes classifying all of its sides, as well as kind of laying the foundation towards later calculations when we go into some trigonometric ratios, things like sine, cosine, tan, which may be familiar to you, but if not, we will get to it in the next video. So here we have a right-angled triangle, and the way we classify that is that two of its edges meet at a right angle. We can say these are perpendicular to one another. And our third side just joins these other two edges. Now, if we go back to what we did in angle geometry, we said that the angle sum of a triangle is 180 degrees. So we have a right angle here. Oops. And this angle, and this angle will all add up to 180 degrees. Now, this right angle here implies that these two lines are going to be split. They're going to be, there's going to be a certain distance between them. And that distance is made by this line, right? And we can see that this angle, just by observation, as well as this angle, they are smaller. The biggest angle here is our 90 degrees, because this one and this one must also add up to 90 degrees, because that's the remaining angles within our triangle. So as a result, both this angle and this angle will be less than 90 degrees. And this will be our biggest angle, our right angle. Now, the side opposite to our right angle, this one here, is what we call our hypotenuse. And the hypotenuse, I'm actually going to spell it here because it's a bit of a weird word. Our hypotenuse is the longest side of our triangle, of our right angle triangle. And I'm actually going to write that here. That's the longest side. Now, why is it the longest side? Well, the angle between these two lines is the biggest. So we'd expect the side opposite that, which links these other two, to be the longest, because it's essentially getting joined to two lines which are the furthest distance apart based on the angle. I hope that makes sense, but that's a way to kind of intuitively understand why this is essentially the longest side. Now, the way we talk about the other sides, I should say, because now we want to define this one and this one. The hypotenuse is constant because it's always going to be the longest side, or the side that is opposite to our right angle. Now, classifying these other two in the context of trigonometry depends on the perspective we look at it. And this is from the perspective of the remaining two angles. And this will be a good precursor towards laying out our trigonometric ratios, which we'll do in the next video. So I'm going to actually draw a couple of things here. So say this is just a field or something, right? Now I'm standing at this angle. I'm this purple dot, and I'm going to say, well, I'm here, and say I'm facing this way. The side I'm looking at, I could say, is opposite to me. This is the opposite side. So I'm actually just going to write that down. And we've actually named these and classified these sides in quite an intuitive way because we're just describing what we're seeing. This side is opposite me. Hence, I'm going to call this side the opposite. And let's label this here. We'll say this is opposite to the angle in question. I've just done quest for short. And what about this final side? So I've identified that, cool, I've got my hypotenuse. That's sweet because that's just in relation to my right angle. I've got a side opposite to me. And I also have a side that's right next to me. So if I were to like look to my left, I'd say, well, cool, I have a side that's immediately next to me. And there is a word that summarizes this. Now, this word is adjacent. So adjacent, I'm going to spell that here. This essentially just means next to. So let's zoom out a bit. This is our entire picture. And, sorry, I didn't actually write next to. Here we go. So, this is how I classify the sides based on where I am. I see that, well, there's one side next to me, which isn't the hypotenuse. This is my adjacent side. I have a side opposite to me, and I have the longest possible side, the one that is across from, well, opposite to my right angle. Here we go. That's great. Well, what if I had a friend who was standing here? I'm gonna draw this as an X. So his perspective, his or her perspective, changes a little bit, doesn't it? Because this person is standing at a different angle. But have a think, is there one thing that is constant here to their perspective? Now, I know that's worded in a bit of a weird way, but what I'm trying to get at is that no matter whether you're standing here or here, you'll be able to see that this will always be your longest side. So the hypotenuse is constant. This classification of this side, by definition of it being across opposite to my right angle in my right angle triangle, it will always be my longest side. It will always be the hypotenuse no matter where we are. But let's look at this triangle from the perspective of my friend here. Well, this side is no longer the opposite for them, is it? Because they are next to this side. And my adjacent is going to be their opposite. So it's all about perspective, right? And I could be arguing with this person. I'm going, well, no, that's my opposite. That's the opposite side. And they'd be saying, well, no, that's my adjacent side. It's all about the perspective of the angle. And in the next video, we're going to look at why this is important and why we kind of rigorously define these side names, our opposites, our adjacents, and our hypotenuses, but more specifically these two, why we define those in relation to which angle we're looking at from these two non-right angles. So I'll see you in the next one, and just leave this lesson here today with this idea that we classify the sides of our triangle based on the perspective from the angle, based on the perspective of the angle in question. And this will all tie in together when we start looking at trigonometric ratios. So I'll see you then.